Hello, hello. We are already part 4 of the conference. Oh, nice. I see some action in the background, in the backstage. Yes.
Hello.
Great
I
job.
feel like now the theme is to have
Yes,
eye mask.
exactly. And then we can fall asleep shortly.
Really
Cool.
like
Yeah,
yours.
no.
Because
Yeah,
mine is just
exactly. The
a
plain
free
one.
gift
This
from
is,
the
this
train.
is, yeah, this is the fun one. So cool. We have another section now. We still have a couple of minutes before we go. We do have more people that were leaving before. So I really curious. Drop under the YouTube comments. Where are you joining from? I am currently joining from Berlin. And you, Chuck, maybe you can repeat where you are.
Yeah, I'm in Barcelona, which is
Oh, so
this is
nice.
not my home. I'm home away from home. Because I just finished joining Pi Day today, Pi Day Barcelona.
Nice.
Um, yeah.
That's really cool. So yeah, let us know, people, where are you joining from? We know that we had already people from the Americas started to join since the last part of the conference. And now in Central European time, is already almost 10 p.m. Not so late, but late enough to be cozy and grabbing some hot beverage and enjoying the next talks.
Yeah.
Okay.
Yeah, this is the mask I use when I'm traveling. So I got that from. So this is actually the logo of the Caledonian Sleeper. So it's a
Oh, I didn't
night
know.
train going from London to Highland in Scotland. So
Oh, nice. I didn't know. I thought that it was the one that they give you in the hotel or maybe in the plane.
no, hotel doesn't give you hotel doesn't need eye mask. You have your own
you,
room.
you asked for one. Like, can I have one? Okay,
Yeah.
cool. So maybe let me share here. We will have now a couple of talks that are recorded, and that doesn't mean that they are like worse or anything. They are really cool. And the first one, you already can see the title here, is the infamous issue, the famous talk that we had in the issues in the morning. But Yasser was kind enough to quickly record the talk, submitting it. We double check it, and everything should work fine now. I have it here ready for you to learn about it. It's a really interesting topic, to be honest, because I mean, it's the first time that I'm looking into SQL, Python, and Async on the same phrase. I don't know about you, Chuck, but it's for me was like, what? You can? And so, really curious.
Yeah, I'm looking forward to watch it.
Cool. So I think that we're already a little bit, a couple of, 1 minute ahead, running late. So maybe just to avoid the people that is waiting for this amazing talk, maybe let's start. So I will remove you and myself and be right back after this talk.
Hello. Sorry for the issue we have this morning regarding my talk of Async database. So my discussion today about the asynchronized databases. We're gonna discuss different stuff regarding the asynchronized code, synchronized code, databases, SQL, Python, and stuff. Bunch of stuff regarding the Python environment and the new design of the new stuff in Python. Let's start. So here is our agenda for today. So my first point is like, why not asynchronize? Why asynchronize? Behind the logic of ORMs, pros, cons for ORMs and stuff. I'm struggling which ORM I'm gonna use. We'll see some ORMs and discuss them. So, and also a quick look into ORM Dontic, ORM that I built. And by the end, just a schema about the overview of this talk. So, who I am, maybe people know me, even know. So I'm Yasser, or call me as. I'm an experienced software engineer, self-taught, and I started doing code 5 years ago, 6 years ago. So I have like a much of bunch of stuff I work on them before and also now. I do also consultant for a bunch of companies and startups. regarding what they need in Fast API, Django stuff, and the others. You can find me on Twitter or on GitHub. Just like copy the username and you'll find me. And let's start. The first part I want to talk about is like, we always start with the bad and go to the good side. It's like a point we don't have a heart attack or something. So let's start with why not asynchronize. So when it's come, why not asynchronize is like, why I will use asynchronized code. Why? So this is like first question I will ask myself: why this code gonna be asynchronized, or why I'm gonna build my model is in a synchronized way? Why? So before that, in many cases, we don't need asynchronized code or asynchronized ORM or asynchronized databases or stuff, because the main reason is like a bunch of people doesn't know how to code it safely and correctly. It's one of the issues that people may take care of it. So we all learn Python in the same way, like YouTube, Google stuff, courses, documentations. We code synchronizedly. 3 years ago, it was like the famous stuff. Now it's like asynchronizedly is like the main one. So this is why. Because the modeling database also are so fast when the query is simple. So I want a query just to select, like, for example, OLs from a specific course. So why I'm gonna make complexity and use this as an asynchronized function or a synchronized query? Why not just like write my query normally and boom, I got the result. So when it comes to simple queries and stuff, it's much better if we use just synchronized code. And this kind of application usually deploy the database in super reliable network. So whenever right now in the modern startups, modern companies, stuff and like that, you will find a bunch of new technologies like AWS, Google GCP, Microsoft Azure, bunch of them. So like they are high technologies with a high, you could say, performance when it's come to I deploy my database and stuff. In this case, like it doesn't make sense to use asynchronized and stuff. So it's like you could say, hi, I want to just Asyncio, or I want to just asynchronized stuff just because I love that, or asynchronized ORM or something. Yeah, and for the pros for the synchronized code, like synchronized programming is best specialized in reactive systems, while it's simpler for developer to code and is recognized by every programming language. Sync is resource intensive and can slow things down, which means everyone like can code just normal code, like not asynchronized stuff, and make things and make weights and understand the model, understanding how it's work, like this process then stop until this gonna complete and stuff. So synchronized programming is like we use it like in a bunch of applications, bunch of big tools, bunch of stuff that doesn't need to have a waiting moment or a function that's need to run progress with another function. So a bunch of stuff. That's why it's like let's keep it simple. Use synchronize and everything gonna be good. So if it's not like something that's depend on asynchronized systems or asynchronized logic, much better if we use synchronized code. Now let's go to the asynchronized part and why we need to use the asynchronized part. So when we said asynchronized, we mean like a multi-threading model that's most applicable to network and communication. Let's say we have, for example, a small system for chatting internally in the company itself. So like, for example, let's say I'm a CTO and the other one is like the software engineer, the team lead. So we are talking about a bunch of stuff. I send a message. So the other team gonna wait me until I complete my message and send it. This is like gonna be so weird. Maybe especially if like I have not a complete idea or something like that. So it's much better like to block me and say, like, for example, the software engineer says his idea and stuff. This is what can be a closest like logic to asynchronized, like chatting system between that. It's much better to use asynchronized code, which means it doesn't block further execution while more operations are in progress, which means like my progress, not blocked before because that. So it's everything gonna run in the same time. With asynchronized programming, multiple related operations can run concurrently without waiting for other tasks to complete. That's what I mean. Like when I, for example, I'm taking the lead to talk, and I mean, like, for example, an issue in what I'm saying, like the other one can just obviously like correct me or like complete what my idea or stuff. This is like concurrency in the discussion or something like that. During the asynchronous communication, parties receive and process message when it's convenient or possible to do, rather than responding immediately upon receipt. Is like that directly. The end, like texting is like a synchronized communication method. One person can send a text and the reception can respond on their leisure in the meantime, which means, like, for example, let's see it as WhatsApp, Instagram, Twitter, chat, stuff like that. You write a message, someone else writes a message in the same time, everyone writes a message in the same time. So this is not gonna block someone from not or like that. This is like one of them. And for like, let's say, famous example or something like that, responsive UI with a great asynchronous planning, shopping application, like let's see Shopify, let's see Amazon, stuff like that. It's like when you use a pool, like a new order or something, the font size like should increase instead of first waiting to load the history and update the font size. Like asynchronously programming can make it both action happen, which means the font size and loading the history of and updates for the others orders and stuff. That's why like asynchronized code much help us to make things work progress one under the other under the one. So that's like that. We're not gonna wait everything to operate on a slow down level. So it's everything like operates in a progress. Every progress gonna run. Every progress are gonna run separately. So that's why asynchronized, it's much used in systems like real time systems like chat, like shopping application, real time feed, like Facebook, stuff like that. So it's much better to use stuff in asynchronized mode or asynchronized ZMO stuff. Let's see now the logic of ORMs to take both, like how we scale from asynchronized and the ORM. So now we understand like asynchronized, difference between asynchronized and synchronized. Now let's understand the ORM and see like what is ORM and SQL level stuff, and let's like make them both in a mix. So the ORMs first is like object relational mapping. It's like a mechanism that make possible to address, access, and manipulate objects without having to consider how those objects related to the data source. How we can understand it is like, see as a table. We have a table of data, or for example, name, phone, address, and stuff. We don't know like who belong to or something like that. We're gonna just use like this mechanism to transport this data into the database without like writing a lot of SQL stuff, writing a lot of stuff to make this possible. And it's like just some easy steps. Take this and put this. But in that mechanism, have the possibility to understand both level of the database gonna receive and send also, and level of the clients who create the tables to send them. So this is how. For example, here is like a completely imaginary case, like how you have a book class, you want to retrieve all the book of which of the author is Linus. Mainly will do something like that. I mean, in SQL level, but also in a code level. So you write like, for example, book list, you create the list, the SQL, you write your query, select book from library where the author is data, you query the SQL, and now you look over it to add or to select or to get or to retrieve. But in the ORM level, let's say in the ORM level, for example, we can retrieve it just with one line. Create just book list equal book table, where we have already the tables assigned with the data and stuff, and the fields and the table's name and stuff like that, and we query that. And we said like to this query, I want the author that called this, and we run this query. It's give us like the results. But how it's work is like when it's transport this query to multi-level, it's see it like it's a SQL code, a SQL progress that send it directly from the ORM itself to the database. That's the language database understand it, which means understand it and responds to the ORM with the result that it wants. Yeah, so this is the books that Linus has. And this is how like ORMs works, and especially this is the logic of them. But not much of times ORMs are good. Not much of times like SQL is good. But we said SQL is the main one. How we're gonna interact with the database, structured one. But ORMs help us to understand both level, the language level and the database. For that, I create like the pros for that and the cons. For the pros, using ORMs save a lot or a ton of times because like don't repeat yourself. You write your data models in one place. Let's see it, for example, if someone here, I guess everyone here gonna be familiar with Django, the MVC format, the model view controller. We have a place where we assign our models and stuff like that, and we don't repeat them. Like we don't write every time like the models in several stuff. Write it in one place, we can update them and migrate them directly. We can reuse the code, and the bunch of ORMs now, the bunch of the ORM have a ton of stuff done automatically. For example, the database handling, maybe the level of error handling and stuff, maybe also the internationalism, a bunch of stuff. It forces you also to write an MVC code when you separate like the models and the view and the controllers and all this stuff in separate way, which like make the code at the end like just clean with we can say a common form at the end. You don't write a bunch of times like SQL and you don't end up like writing a bunch of queries. You need to check them. You need to run this query in a SQLite database to test if this work, if this not, if this, what if this gonna cause us a SQL injection? What if we didn't like properly make our SQL code safe and stuff? Most of web application really suck at it. I mean, web programmers and people who do programming, I mean, the new generation programming doesn't get deep stuff into SQL. And that's why it's treated like a sub-languages when it's reality, it's a very powerful and complex one. Sometimes like using program statement transactional really is called. Using ORM library is more flexible because it's fit in a new natural way of coding. For example, in Python, we have a bunch of libraries. We're gonna see them at the end. It's abstract the DB system, so you can change it whenever you want. A bunch of times, like we have the options. Let's say today I create my SQL stuff in SQLite. I wanna deploy them. Of course, I'm not gonna deploy SQLite database. I'm gonna use Postgres. So just changing the URL and everything gonna work fine. This is how. The model is weakly bound to the rest of the application, so you can change it or use it anywhere else. So I mean, like the model is separately between every part of our views, controller stuff. It lets you use the OOP. The goodness like data inheritance without a headache. Like we all love OOP. We all love like coding stuff in general way to find like the easiest way to find a bunch of stuff. Yeah, so this is like one of the I see them as a pros for using ORMs, but for the cons, it can be a pain when you have to learn an ORM and not to tools, which means you need to understand, for example, in Django ORM or SQL Alchemy or a bunch of other ORMs, you need to understand them deeply to know when to use this and when to not use this. And this is how you have to set up it always. Like if you didn't set up everything good, you gotta have everything separately. Have a bunch of issues there. Well, also in the performance level, if we see SQL performance, it's much lightweight than the ORM. So if we own like a big projects and we use like a bunch of SQL stuff, it's gonna make them lightweight, not take a bunch of times. But when we write like queries with you depend on ORMs. Sometimes it's gonna cause us a lot of tons of waiting just to perform this, especially in big projects, especially in really big projects that scale. It's abstract the DB. While it's okay if you want like to don't know the scenarios or what happening behind the scene, it's a trap for new programmer that can write very greedy statement, like a heavy hit of for loops and stuff like that. So sometimes understanding the abstract, it's help the developer to know himself, to know a bunch of issues, a bunch of stuff. So like this is gonna be helpful to not use the ORM until you want also to explore the what happened behind scenes and scenarios. Yeah, I'm so glad now what ORM I will use. We have in Python a bunch of them, especially like I'm now in a Pyjamas, which means like a Python conference. My favorite, or the normal state everyone uses, SQL Alchemy. It's like the famous one, written by Mike Bayer and SQL Alchemy team. Like one of my favorite ORMs exists. Like, I use it, and the Django ORM too. It's like from the Django project itself. Is like the one that uses in Django, and it's also good and amazing. We have Peewee, we have Pony ORM, we have SQL Object, we have Tortoise, we have other ones like I try to remember one of them. Like I have also SQL model from Sebastian itself, the creator of SCPI. We have ORM Don't Kick that we're gonna discuss about it. It's like something that I inspire from a bunch of other ORMs built, and I'm trying to make it using a bunch of tools. So it's important until now, like just asynchronous code. There is other tools like Storms, a bunch of them. And if you go like for other languages like Java, PHP, JavaScript, other stuff, you will find other ORMs also support a bunch of stuff. So that's why we have multiple stuff we use. You can just go take some time, play around sometimes in the database, into the documentation itself, read it, understand what happened, see scenarios, try them into your local, and with that you can understand SQL Alchemy or other ORMs that you see here, or the other ORMs, you know them. So yeah, I forget also to mention Piccolo is one also of the good ORMs now in the new generation. I love it, by the way. It's like if I want like maybe now my stack, maybe if I want like to start a new fast API project, like my own stuff, I could use it with the Piccolo and like that. It's like one of the amazing. And also there's Tortoise or SQL model or SQL Alchemy, the base one. Yeah, now let's pass through ORM Don't Check one. This one I baked this one. It's like based on PyPika. It's like Python query API. Like everything, take the abstract of SQL stuff and write them into queries and make things facilities. And also powered by Pydantic and SQL Alchemy. Everyone know the Pydantic, the model stuff, how Pydantic help us, how Pydantic is amazing and stuff. And SQL Alchemy, it's highly inspired by SQL model created by Sebastian. And yeah, it's sensible. Like you can just write code that will work underneath. It's combined a bunch of amazing tools. Like you can extend other features are in Pydantic or SQL Alchemy, PyPika itself, and try to simplify the code, like writing minimum and reduce like a bunch of stuff like code duplication. Also give like the developer the best experience. It's extensible. Yeah, I mean, like you can use also the power of SQL Alchemy on top of it, or PyPika also. Short queries, like we're gonna see a quick demo, maybe like just a quick demo to see how stuff works here and understand like the schema of it. So yeah, the quick overview before the demo, I guess we can like just like abstract stuff. I'm gonna for example just like show you a design of it. Maybe let me just change my output screen, because I was doing like this one, not just this one. I'm gonna use yeah, so I guess this one gonna work fine. Where is this? Yes, so I'm sorry for that. I cut it and complete. So to complete what we start is like I told you like a demo to understand what is ORM logic. So ORM logic, like it's help us just to create, for example, the SQL Alchemy engine. It's baked with SQL Alchemy in the when you create the engine, just the connection database, you call it, and you create the database. For creating the tables, you just like create your model, your Pydantic model normally, like for example, flavor or something else like coffee, car stuff. You create that table normally like in Pydantic, but you add a parameter, stuff like database, the table, you add it accepts primary key, the index, the foreign key, back reference, unique constraints and stuff. It's like here we call the decorator and stuff. And also, yeah, it support other queries. Like when we initial the database, we answer the database. For example, this one for answer, it's like answering stuff is like answer the flavor. For example, we create a flavor name. It's called vanilla. We answer it directly. Database flavor answers vanilla. So this is how we do also searching, find one, find many, find in depth with the to search with other stuff like where, order by, order limits, offset, and depth stuff. We have the update and the upsert. Yeah, also count and delete. And I'm still working on develop it. Also, people can ask if they have some experience with SQL model and stuff. They ask what is the point of difference. Yeah. So, for example, in the multimorphism, it's like inherited from Pydantic base model, SQL model, and use a modified SQL Alchemy base model as a meta class. But Orendontic use a wrapper or decorator to make Pydantic base model behave like database table as well. For the database connection, SQL model is not built like it's handled with creation sign. The Orendontic just take the screen. It's like just take the string as a constructor parameter. It's like async by default. And for the API stuff, is like you typically interact with both the session objects and the SQL model object. But here in Orendontic, you interact like PonyORM stuff with the database abstraction. The syntax is like similar to PonyORM, which means like you can write queries into database with the Python generation expression and that stuff. So it's structured like a SQL queries. In the background, yeah, SQL model is created by Sebastian, and this one's like just new and still development stuff. Yeah, so to complete that, here is a quick overview of what we're gonna understand from both like ORMs and synchronized code. So synchronized processing, just remember like this is like database stuff. You gotta need to understand what's happening is like process A and process B. So it's a synchronized code. It's gonna just call the process A. Process A is run when we call the process B. It's stopped. We run the process B, and again we go to the process A. So this is how it's work in synchronized level. In asynchronized level, it's work like we have the process A and the process B. We run the process B. Both of them run. We complete them, which means we run process A and process B at the same time. And this is how it's like. Hope like you got understand what happened here generally. Yeah. So this is the whole idea and a bunch of idea I would like to share with you regarding the asynchronized stuff and the ORM stuff, just to make sure everyone understand them. Yes. So if you have like a question, I'm sorry if I didn't like join the meeting because of the talk because of the issues of connection and stuff. Yeah, if you have any questions, you can find me on Twitter, just THYasser1 or just TS123 and you will find me. And let's catch up there. Thank you so much and see you on another.